Hello, friends. Imagine you are floating in a vast empty space. Everything around you is dark, silent, and endless. You try to think about where you are, but it's hard to understand. What if everything you know about space and time is not real? This question might seem strange, but it's a topic that scientists and philosophers have been thinking about for a long time. In our daily lives, we experience space as the area around us. We can see, touch, and move through it. We know that if we walk from one place to another, we are traveling through space. Time is also something we experience. We know that it passes, and we can measure it with clocks and calendars. But what if these experiences are not real? What if they are just ways our brains understand the world? To start, let's think about what space is. Scientists describe space as the three-dimensional area in which everything exists. This means that everything has a position in space. And we can measure distances between things. For example, you can measure the distance from your house to your school. But some scientists believe that space might not be as real as we think. They suggest that space could be an illusion, something our minds create to help us understand the world. One idea is that space is a result of how our brains process information. When we see objects, our brains use the information from our eyes to create a sense of space. This means that space might not exist outside of our minds. Instead, it could be a way for our brains to organize the information they receive. Now let's think about time. We experience time as a continuous flow from the past to the present and into the future. We can remember things that happened before, and we can make plans for things that will happen later. But some scientists and philosophers believe that time might also be an illusion. They suggest that time could be a way for our minds to make sense of changes in the world. One idea is that time is a result of how we perceive changes. When we see something change, our brains create a sense of time passing. This means that time might not exist outside of our minds. Instead, it could be a way for our brains to organize the information they receive about changes in the world. To understand these ideas better, let's think about a video game. In a video game, you can move through a virtual world and experience events happening in a sequence. But the world and the events are not real. They are created by the computer and exist only in the game. Some scientists and philosophers believe that our experience of space and time might be similar. They suggest that the world we experience might be a kind of virtual reality created by our minds. One theory that explores this idea is called the holographic principle. This theory suggests that the entire universe could be like a hologram. A hologram is a three-dimensional image created from a two-dimensional surface. The holographic principle suggests that the three-dimensional universe we experience could be created from information on a two-dimensional surface. This means that space and time might be emergent properties, things that arise from something more fundamental. Another idea is that space and time are part of a larger framework called space-time. Space-time is the combination of space and time into a single entity. In this framework, space and time are not separate, but are interconnected. This idea comes from Albert Einstein's theory of relativity, which describes how space and time are affected by gravity and motion. According to this theory, space-time can be curved and warped by massive objects like stars and planets. But some scientists believe that space-time might not be fundamental. They suggest that space-time could be an emergent property, something that arises from even more basic elements. One idea is that space-time could be made up of tiny discrete units called quanta. These quanta could be like the pixels on a computer screen, which combine to create a continuous image. If this is true, then space and time might not be continuous, but could be made up of tiny, discrete pieces. Another idea is that space and time are part of a larger, more complex structure called a quantum foam. Quantum foam is a concept from quantum mechanics which describes the behavior of particles on a very small scale. According to this idea, space-time could be like a frothy, bubbling foam made up of tiny, fluctuating regions. In this view, space and time might not be smooth and continuous, but could be constantly changing and fluctuating on a very small scale. To explore these ideas further, scientists use mathematical models and experiments. They study the behavior of particles and fields to understand how space and time might arise from more basic elements. They also use experiments with high-energy particles to probe the structure of space-time on very small scales. One of the key tools scientists use to study space and time is the Large Hadron Collider, LHC. The LHC is a huge particle accelerator that can smash particles together at very high energies. By studying the collisions, scientists can learn about the fundamental properties of particles and forces. They hope to find clues about the nature of space and time and how they might arise from more basic elements. Another tool scientists use is the study of black holes. Black holes are regions of space where gravity is so strong that nothing can escape. They are formed when massive stars collapse under their own gravity. Black holes provide a unique environment to study the behavior of space-time under extreme conditions. By studying black holes, scientists hope to learn more about the fundamental nature of space and time. One of the most exciting ideas in this field is the possibility that space and time might be connected to information. Some scientists believe that the universe could be like a giant computer, processing information at a fundamental level. According to this idea, space and time could be the result of how information is processed and organized. This idea is known as the computational universe, and it suggests that the fundamental nature of reality might be based on information rather than physical objects. Expanding on these points further, let's consider how ancient civilizations viewed space and time. Many ancient cultures had their own unique ways of understanding the cosmos. For example, ancient Greeks believed in a geocentric model where Earth was the center of the universe, and everything else revolved around it. This view was held for many centuries until it was replaced by the heliocentric model, where the sun is at the center. These shifts in understanding show how our perceptions of space and time can change over time. In contrast, some Eastern philosophies, such as those found in Hinduism and Buddhism, have different views of space and time. In Hindu cosmology, time is cyclical, with endless cycles of creation and destruction. This idea contrasts with the linear view of time found in many Western cultures. These different perspectives highlight the diversity of ways humans have tried to understand space and time throughout history. Another interesting aspect to consider is the role of mathematics in our understanding of space and time. Mathematics is a powerful tool that allows us to describe and predict the behavior of the universe. Concepts like geometry, algebra, and calculus help us make sense of the spatial and temporal dimensions. For example, Einstein's theory of relativity relies heavily on complex mathematical equations to describe how space and time interact. These mathematical frameworks provide a deeper insight into the nature of reality. Moreover, advancements in technology have significantly impacted our understanding of space and time. Telescopes, satellites, and space probes have allowed us to explore the far reaches of the universe, providing us with a wealth of data about distant galaxies, stars, and planets. These observations have led to new theories and models that challenge our traditional views of space and time. For instance, the discovery of the cosmic microwave background radiation provided strong evidence for the Big Bang theory, which describes the origin and evolution of the universe. This discovery has profound implications for our understanding of space and time, suggesting that the universe has a finite beginning and has been expanding ever since. The study of cosmic inflation, a rapid expansion of the universe shortly after the Big Bang, further challenges our notions of space and time. Another groundbreaking discovery is the detection of gravitational waves. These ripples in space-time, caused by violent cosmic events like colliding black holes, provide direct evidence of the dynamic nature of space-time predicted by Einstein's theory of relativity. Gravitational wave astronomy is a rapidly growing field that promises to unveil new insights into the fabric of the universe. Considering the potential implications of these discoveries, let's explore the idea of parallel universes. Some theories in physics, such as the multiverse theory, suggest that our universe might be just one of many universes existing in a larger multiverse. In this view, space and time might be different in other universes with different physical laws and dimensions. This idea challenges our understanding of reality and opens up new possibilities for exploring the nature of space and time. Another intriguing concept is the idea of time travel. Popularized by science fiction, time travel involves moving backward or forward in time. While it remains purely theoretical, some scientific theories suggest that it might be possible under certain conditions. For example, Einstein's theory of relativity allows for the possibility of time dilation, where time passes at different rates depending on the relative speed and gravity. Wormholes, hypothetical shortcuts through space-time, are another theoretical possibility for time travel. Although these ideas are speculative, they inspire us to think about the nature of time in new and creative ways. Furthermore, the study of quantum mechanics has revealed strange and counterintuitive aspects of reality. Quantum entanglement, where particles become linked and instantly affect each other regardless of distance, suggests that space and time might not be as fundamental as we think. Some interpretations of quantum mechanics propose that reality is fundamentally interconnected, challenging our traditional views of space and time. Another important consideration is the role of consciousness in our experience of space and time. Some philosophers and scientists argue that our perception of space and time is closely tied to our conscious experience. They suggest that space and time might be constructs created by our minds to make sense of the world. This idea raises profound questions about the nature of reality and the relationship between mind and matter. Additionally, exploring the philosophical implications of these ideas can deepen our understanding. For example, the concept of determinism suggests that all events are predetermined by prior causes, challenging the idea of free will. If space and time are not real, it could imply that our choices and actions are part of a predetermined sequence. This raises important questions about the nature of human agency and responsibility. Moreover, the study of space and time can have practical implications for technology and society. For example, understanding the nature of space-time is crucial for developing advanced technologies like GPS, which relies on precise measurements of time and space. Advances in our understanding of space and time could lead to new technologies and innovations that transform our world. In conclusion, the idea that space and time might not be real is a fascinating and complex topic that touches on many aspects of science, philosophy, and human experience. By exploring these ideas, we can gain a deeper understanding of the nature of reality and our place in the universe. While these ideas are still being explored and debated, they offer exciting possibilities for expanding our knowledge and pushing the boundaries of our understanding. By thinking about space and time in new and creative ways, we can unlock new insights and discoveries that enrich our understanding of the cosmos and our place within it. As we delve deeper into the nature of space and time, it becomes clear that our understanding is constantly evolving. New discoveries and theories continue to challenge our perceptions and open up new avenues of exploration. Whether through the study of black holes, the mysteries of quantum mechanics, or the philosophical implications of our conscious experience, the quest to understand space and time remains one of the most profound and exciting journeys in human history. If you like this video, please like, comment, and share the video, and please do not forget to subscribe for more videos.